Good lighting plays a very important role when it comes to making videos and even taking photos. A good light panel is always nice to have in your video gear. As usual, there are always options to choose from and buy them for a lot of money, but there is no fun in that, so let's DIY it. This one has adjustable brightness and also adjustable color temperature. I was able to reduce the ISO by about 2 stops with this LED panel. That's a big win-win. Just so you know, with this DIY project I am going for the cheap and best solution. I used LED strips of 2 different colors, white and warm white. This allows me to change the color temperature of the final output light. Let's start with the panel which will hold all the LED strips. I decided to go with a circular panel instead of the usual rectangle and squares. Also, I found these embroidery rings which would work perfectly as the frame. I cut out the circles from a cardboard and drew equidistant lines so that it's easy to align the LED strips while sticking them to the cardboard panel. Next, I cut the LED strips to required lengths. The adhesive on the LED strips was pretty good and sticking them to the panel was straightforward. I initially went with a 50-50 ratio white to warm white colors, but the light turned out a little too warm and hence later I made the white to warm white ratio to 70-30. Next, I drilled tiny holes next to the LED strip terminals, warm whites on one side and the whites on the other side. I soldered the terminals using some tiny black and red wires. These wires are amazing and are very handy for soldering circuits. You can find the purchase links in the description. These wires get routed through the tiny holes after soldering. After soldering all the wires, we have this bacterium-like looking panel with all the wires from individual LED strips poking out. Next, I made 2 pairs of thick copper wires by stripping off individual wires from an Ethernet cable and twisting them together. These wires will connect all the white and warm white LED strips in parallel respectively. After gluing down the copper wire pairs, I started soldering the individual leads from LED strips to the copper wires. In the meantime, I also added a drop of glue into the tiny holes so that there is no tension created on the solder joints. Once this was done, I covered them with electrical tape so that the solder joints are not exposed. After making sure that all the individual LED strips lit up, I soldered the power leads to the copper wire terminals of the ganged up white and warm white LED strips. I also measured the maximum current draw of the LED panel so that I can select a power source accordingly. Once this was done, it was time to prep the frame. I used 2-component epoxy to stick 2 of the same sized embroidery rings. Later painted the inside of the ring with white paint because white reflects color in a very natural way. I slowly and carefully drilled a hole on the spot where the 2 rings meet. I made the hole big enough to fit in the tripod screw adapter snugly without needing any glue. Fortunately, the epoxy held up and the rings didn't break off. With the tripod mount in, I can easily attach the LED panel anywhere, on a tiny tripod, on a big tripod, to the top of my table, and anywhere I can find the standard tripod mount screw. I use lots of hot glue to stick the frame to the LED panel. Let's talk about the circuit which will drive this dimmable LED panel. My primary objective with the circuitry was to be able to dim white and the warm white colors individually. After a lot of trial and errors, I finalized on a PWM driven timer circuit. Yes, PWM. It is usually not recommended to go with PWM based control for video lights as they are prone to flickering when there is a mismatch of PWM frequency and the video frame rate. But with a high enough PWM frequency, flickering can be avoided completely at common video frame rates. This circuit is tuned to around 30 kHz and I've not noticed any flicker. Even with the highest frame rate my camera was capable of recording. Notice that the frequency is higher than 20 kHz, which is where the human ears can hear. If the frequency is lower than 20 kHz, the circuit produces a high-pitched sound which is damn annoying. The LM556 has 2 555 timers built into the same IC. I will be using one timer for the white and the other for warm white respectively. Using the timers in a bistable mode, we can get the output duty cycle to vary from 0 to around 95% at the same frequency. After testing the circuit on a breadboard, I made a schematic using the Easy EDA software. Next, I used this schematic to make a more permanent board. I used IRFZ44N MOSFETs as switches for each the white and the warm white LED strips. I will have the schematic linked in the description down below. You can use that to make your own dimmer circuit. Make sure to use a good quality potentiometer which will be used for brightness control. I decided upon a 12 volt 5 amp capable power supply to drive the panel, enough juice for all the LED strips. I attached another embroidery ring to the back of the panel using hot glue. This will protect the panel and will also provide better structural integrity. I attached the power supply to the back of the LED panel using Velcro so that it is easy to detach and can be replaced with a battery pack. I made a small cardboard panel to mount the potentiometers and stuck them to the ring on the back of the LED panel. Next, I glued the circuit to the back of the LED panel and used these handy JSW connectors to interconnect everything. The brightness varies from about 10% to 90%. Capping the maximum brightness to around 90% helps to extend the lifespan of the LEDs. The color temperature can also be varied from warm to cold by adjusting the brightness of individual colors. Because there are so many LEDs, the light out of this panel is quite soft. This LED panel can now be used to light up scenes evenly and can also be used to take photographs. It gets quite bright at the maximum brightness and produces a very pleasant daylight. Not too cold and not too warm. Even though this project took a long time, I am quite happy with it. Now go build one yourself. Feel free to make any changes to suit your needs and don't be shy to be creative. Thanks for watching this video. I hope you enjoyed it and learned something new. You can find the schematic and all the purchasing links in the description below. Feel free to subscribe for more videos.